So yeah, really, really excited. This is like a relatively fun idea for us, which is blending robotics and blockchains. And we think there's some values that blockchains share that are incredibly useful for building robotic systems. So yeah, why robotics? Well, yeah, we envision a future where robotics are going to be operating in unconstrained environments. So today, they're typically deployed in factories. These are highly constrained environments. And of course, the rules inside the factories are very different to the rules for robots operating in open systems. So concepts such as safety become critical. I'm sure we've all been in a Waymo. I mean, if you put your hand up if you came here in a Waymo. Yeah, quite a few of us already. So we're all pretty familiar with just how dangerous these devices could be if they malfunction. The second piece is we think robots are going to be operating in collaborative environments. And this means that humans are going to be working alongside robots. And it means we are going to be placing a great deal of trust in the robotic systems that we're going to be interacting with. And the third piece is we think these interactions are going to be routine. They're going to extend into our homes. They're going to extend into the open environments around us. And in 10 or 15 years' time, it's not going to be unreasonable to expect that we will probably be interacting with robots on a day-to-day basis. I mean, in San Francisco, people already do. They take taxis, robo-taxis, and there's no human operators, no human drivers. So this is very much a reality, and it's going to become global. It's going to become ubiquitous. It's going to become widespread. And yeah, we see this. There's some very exciting hardware being developed today. These are all single-operator hardware systems. You can see there's UASs. These are zipline drones that can autonomously navigate in remote environments. We have humanoid robots. Just a few here is the Figure robot, which is the top center. We have the Chinese variant of a Figure as well. And we also have the 1X system, which is designed to operate in homes. It's a kind of more of a safety-considerate robot. And then, of course, we have the self-driving taxis, which are potentially the most lethal systems of all of these, just because they have a lot of mass. And so, obviously, when we think about multi-operator robotics, where we have multiple different robotaxi operators, for example, they might want to securely share information with each other. And they might not also be able to communicate with each other. They might not be connected to the network. There's potential attacks and exploits. So having some form of localized form of trust is going to be very, very important. And yeah, as I spoke about this before, the penalty for failure is extremely high for robotic systems. If a software system breaks, if a web server hosting my website, or even say all of the validators hosting a blockchain fail, in AWS or in a server or a data center, or maybe my bank servers fail, really the ramifications, the penalty for failure is maybe I can't pay someone, maybe somebody loses a little bit of money. It's not great. And there are some environments where software systems are critical, like in medical. But when we talk about physical systems and failures of physical systems, which are underpinned by software, then the ramifications or the penalty for failure really are catastrophic. If a car crashes, it could result in loss of human life or fatalities. So these problems are immensely important. They're immensely valuable and somewhat underappreciated, actually, in my opinion. I think people get very excited about this kind of unconstrained open tech, but they don't really seem to make a lot of considerations about safety. And as always, failure is to be expected. So unfortunately, devices might work, 99.99999% of the time, but it's that edge case that is still going to result in the system failing. And I kind of like the kind of trolley problem analogy. It's nice to know what kind of decisions a robot made. This is maybe more of an ethics question, but having some kind of immutable record where you could store information about robotic decision-making, and other robots around it and other humans could verify and audit that robotic decision-making, that they could prove that the decisions made by the robot were made by a model that's been validated, and they can prove that the hardware was never tampered with, is going to become really, really important. Because when we have lots of these robots, we have very, very complex scenarios which might arise. And these robots need to make autonomous decisions. And as you can see here, this is maybe very kind of a very jovial representation. But yeah, we have lots of trolley problems in very complex environments. And so what are the kind of guarantees that blockchains can provide us with? Well, really, there's tamper resistance. So we can publish signatures about physical hardware to prove that the hardware is running a certain type of software, that the hardware itself hasn't been tampered with. And we could publish that to an immutable ledger. So that's very, very valuable. The second piece is we can authenticate messages. So we can authenticate the source or the origin of a message and tie it back to a physical device. And this really brings in concepts such as device identity. And we're really, really interested in really how we can create large networks of device identity, similar to what World is working on. World is working on a human identity platform, Proof of Humanity. And it's not unreasonable to expect that we could create platforms or basically primitives for robots to be able to communicate with each other on blockchains and share information or signatures securely with each other. And the last piece is really state conflict resolution. And I think this is really, really cool. There's things, concepts such as UTMs, which are unmanned traffic systems. And when you have very large networks of operators, you may want to create like an economy around the provision of airspace for drones, or an economy around the provision of terrestrial space, of notion of traffic for autonomous cars. How do we prioritize the actions of autonomous vehicles? And something like an ambulance, for example, might take precedent over myself commuting to work. And there's many other examples here where we can apply these kind of economic systems and economic concepts from blockchains to robotics and robots operating in open environments. So this is super, super exciting stuff. And of course, this is really scratching the surface of all of the potential applications and intersections between blockchain technology and distributed ledgers and permissionless open distributed ledgers, such as Ethereum and all of the scalable rollups, and physical hardware. And I think we're at a really interesting intersection, a really interesting point now, where we're now reaching beyond the kind of the virtual trust boundary and exploring the kind of physical realm of bits and atoms. And this is really, really exciting point in time where there's lots of these robotic projects and actual applied demonstrations of robotic systems such as Waymo taxis. And yeah, I think this is going to be very, very exciting over the next couple of years. So with all of this in mind, with the kind of the problem space I spelled out, we have given some ideas. We purposefully left this quite vague. I wouldn't say vague, but maybe open, actually, just because we want to give people the space to explore really any idea that's potentially related to robotics. And, you don't need to scratch, you don't need to dig really into physical hardware systems, but even ideas that touch ML, machine learning, and the models that might run on robots are also highly relevant to this hackathon. So the first one was robotic identity. Now, robotic identity we think is going to be really, really important. In a multi-operator system, say we have large distributed autonomous taxi networks, there are a lot of kind of concepts that are required around ownership and control of the robots that are really going to be underpinned by identity. And this is things like, who owns the robotaxi? Where does the value accrue to? If the taxi crashes, for any situation, where does the liability, who's responsible for liability for an accident? And so having a kind of immutable, verifiable on-chain credential system that is also tamper-proof, which means that, I couldn't extract the chips from my taxi or my friend's taxi and put them in my taxi and, try and spoof the system. These are immensely valuable. And we think about these as kind of a primitive where blockchain is highly relevant. It's a really, really, really good use case. And it's why we think this kind of these proof of humanity identity systems can really be extended into proof of machine or proof of AI kind of model systems. The second piece is secure communications. So blockchains are very good for securely sharing messages with a network. And we think that open peer-to-peer vehicle-to-everything communication networks are going to become really, really important. Now, there are attacks today which are highly relevant here. A lot of the systems that we use depend on these kind of centralized or semi-centralized communication networks to share information. And these include things like 5G and 4G, and they also include GPS, actually, to passively receive location information. So in a scenario where a sophisticated attacker might use a jammer, a low-cost jammer, to jam out 5G radio waves or 5G frequencies, or jam out the GPS frequencies, these robots really can't operate at all. So if there's methods for robots in their local vicinity to securely share information with each other, and also proof that that information is trustworthy, that it was perhaps derived from real sensors rather than synthetic, and wasn't spoofed, again, that would be a very, very valuable use case of blockchain. It takes advantage of immutable ledgers. It could also take advantage of an identity system. And some of the other ideas that extend into this are really around decision making. You might have a swarm of robots, so you have like a search and rescue swarm of UASs. How can they efficiently allocate tasks to each other over what kind of areas they want to search? And the last piece is really shared learning. And this is maybe applicable in closed environments, but also very applicable in open environments. The world we live in is not stationary. And this is particularly important in kind of, if anyone who's here has ever worked with geographical systems, maps change all the time. The world around us changes all the time. New buildings are built, roadworks are put up. The world is a very dynamic place. And it's very important that these systems are able to share securely information about the dynamic world around us. And again, we think that using a blockchain, using an immutable ledger, an immutable record is a very, very good use case for this. One of the ones that I really am a massive fan of is secure hardware and verifiable computing. And this is really about providing guarantees and assurances to end users about the integrity of a process on a piece of hardware, the correctness of the software it's running. And there's some really, really exciting tech. This is really at the intersection of, I'd say, hardware manufacturing and also cryptography. And here we can verify that, if you stepped into a taxi, a robotaxi, for example, this is one example, you could verify that the model the taxi was running was like a canonical version of a safe, formally verified and pen-tested and correct self-driving model. Or the model itself hasn't been tampered with. It's not beyond the realm of the imagination to think that some nefarious actors could potentially interfere with robotaxis and cause a great deal of harm. So being able to verify the integrity of the hardware, the software systems would be really, really useful. And the last piece is actually supply chain. As we start to kind of get more and more interested in trusted execution environments, the root of trust is something that's really, really important for TEs to verify that the observability of the private keys or the puffs, or we call them physically unclonable functions, which is a physical measurement which is made over a device, is secure, that it hasn't been tampered with, that some nefarious party isn't aware of this very important element of the hardware, which is used to derive a secure cryptographic key. This is really, really important for trusted execution environments. It's still kind of like an unsolved problem. And we'd be very interested, this is more of a theoretical one, in hearing people have like supply chain applied blockchain solutions. And the last piece is data provenance. And this is really, really poignant. I'm sure some of you may have seen the World Conference yesterday. There was a very cool kind of demonstration of proof humanity and how it could be applied to verify someone using a deep face model on Zoom, or verify if they were using a deep face model, if they were real. And this is going to become increasingly relevant in the future. I mean, these kind of models that can change your face are really, really lightweight. I can go on GitHub and find about 100 of these. And it's really, really easy now to generate synthetic data, and it's quite scary. There are some real political kind of ramifications. I mean, we're approaching election season in the US for this technology. And so being able to verify that information was collected by a physical device, by a real device, by a camera, is a really, really, really interesting concept for us. And we think for robots, this also extends into the kind of autonomous agents realm. Robots might want to share sensor information with each other and be able to verify that that information was untampered, that it was collected by a real sensor, a real device, is really, really important. To make sure, in this big, unconstrained, open environment, that the robots are all using real data. They're not, trying to trick each other or trying to manipulate each other. And so this is the hackathon. We're really, really open here. You really just need to incorporate some use case of a blockchain. It can be ECDSA, but really, we can be even more open than that. And the submission doesn't require you to actually build any hardware. We appreciate 2 days is not a lot of time. And really, we want you to create or come up with an exciting, interesting use case of blockchain that is relevant to robotics. And we'd just love to hear what people come up with. Genuine, original, kind of innovative ideas are going to be the winners. And of course, there is a bonus if you can create a working prototype. It could be something that runs on a phone. It could be something that maybe runs on a piece of hardware. It would be super impressive if any of you have brought hardware with you, like a drone or a small robot. And really, really interested to hear what people have to build. So, great. Does anyone have any questions?
How do you apply this robotics environment to blockchain? Can you explain a little bit more on that?
Yeah, there's quite a few kind of open libraries. There's ROS, Robotic Operating System. And ROS is currently used for sharing secure messages inside of a robotic environment. It's basically a Linux operating system. And there are a couple of libraries, I can share them, which can be used to publish these messages on chain. So that's kind of like quite a good starting point. But again, as I said, this is quite like an open book, hackathon. There's also some prior art around data authenticity and provenance. You might have heard of the Content Authenticity Initiative, which is backed by some very big names such as Adobe and OpenAI. And that's kind of an open standard for generating these authenticity or provenance signatures. So that's also a very good place to start. But again, it's not kind of blockchain native. It's for a very narrow set of use cases. And so we're really looking for people to take either original new ideas or existing technologies and extend their use case by applying blockchain. Yeah, so here, proving decision-making process, proving that a model was behaving as it should, the output is correct. This is something that you can kind of already do with LLMs, but it's also something that could be extended into a robotic system as well. Sorry? Of course, yes. I'll share these slides afterwards if you come up and... Yeah, so... Yes. So the Apple uses trusted execution environments, and what they allow the guarantees they provide to users is that users can share basically encrypted information with the trusted execution environment, and the trusted execution environment can securely decrypt the information, perform a computational process, and then re-encrypt the output. And this is really important because ZK is not very good for very computationally expensive processes, and fully homomorphic encryption hardware just doesn't really exist yet for these kind of complex processes. So it provides a guarantee that the process running inside of a physical hardware is non-observable to an external user. And this might be really, really useful for robotics use case. Yeah.
the motherboard and then connect it.
Yeah, they use something called a physical or physically unclonable function. Yeah.
So is this what you're looking for other devices?
Yeah, I think those functions, so device ID, the serial, could be a very good basis for a robotic identity system.
Such use cases, yeah.
Exactly. Thank you, everyone. I think we're on time, but great. Thank you very much, and look forward to seeing what you come up with if you choose to work on this hackathon.